Becky is the bridge management engineer for UDOT, overseeing bridge planning, programming, inspection, and load rating. Please help me welcome Becky.
All right, thank you guys. I'm going to talk a little bit about how UDOT is leveraging our inspection data in order to feed our planning process and also our scoping for our projects moving forward, and kind of some of the steps we've put in place to work towards consistency of our inspections and also integration between our planning group and our inspection group. So the UDOT structures group is all centrally located. We're all out of one office and we deal with all of the bridges statewide. We're broken up into 3 groups with geotech, design, and then bridge management. As part of the bridge management group, I oversee load ratings, inspections, planning, and programming. And so we're a pretty tight group, and we've got a lot of collaboration that happens between the groups because we're all right there, and we're able to look at the system as a whole and also start working between the 2 groups to try and get that consistency and that knowledge that we can pass back and forth. UDOT has been doing element level inspections since the 1990s with the AASHTO core elements, and we went to the AASHTO bridge elements in 2014. It's been a lot more consistent. There's been a little more as far as documentation that we've needed to do, but the consistency and also the definitions of the elements are a lot more refined with the AASHTO elements. Another thing that we've been doing as part of that is we've been identifying work candidates since about that same time frame. When our inspectors are out in the field, they're identifying maintenance work candidates, they're identifying our contractor items, they're identifying safety items. We have a predefined list of work candidates so that they can categorize them into what the work is that's needed, and we can go through our database and we can search it and compile all of the bridges that need a new overlay or all of the bridges that need pothole patching. And with the standardized language, it makes it a lot easier to be able to query that data and bring it forward. They're also identifying priorities and assigning it to whether it goes out to our maintenance group or whether it goes to our planning group to look for prioritization of funding. So each time we complete a cycle, we meet with our maintenance stations as well, and we provide them with a list of all of their bridges that have their work candidates with their prioritization of getting those work candidates completed. That's how we're communicating back to our maintenance stations. They work with us pretty closely and coordinate back when they do get this work done so that we can update it in our database as well. Like I said, we've been doing the element level inspection. It's a lot more detailed than just the NBI. We found that with just using the NBI data, we weren't getting the prioritization or looking at some of those smaller defects or the more minor elements. They were getting lost in the NBI data because it is such a global overall look. So this allows us to quantify those defects, and we're able to give additional documentation and get a lot more information out of it. One thing that we've really kind of pushed home with our inspection groups is that not all defects are created equal. If you've got a condition state 3 crack, you're not necessarily going to go out and take care of that. If you're not starting to see delaminations, you're not starting to see spalls. And so we've started using the defect elements on condition states 3 and 4 a little bit. We haven't fully implemented it, but we have started using it. So we can see, yes, it's condition state 3, but it's a minor issue. Maybe we need to go out and seal it. It's not as high a priority as if you have a condition state 3 pothole in a bridge deck that needs to get out for safety reasons and get addressed right away. It's also been really nice that we've been able to separate out the bridge joints, and we've really stressed this one with our inspection group as well, is this is one of those minor elements that can have huge implications down the line. If you've got a leaking joint, you're dumping water and chlorides down onto your beam ends and your abutments and your beam seats, and so you're causing a lot more deterioration. And so we've kind of talked to our inspection group about that to kind of stress that and bring it home. This is one of our bridges that had a leaking joint back in 2007, and by the time we hit 2016, we'd lost the whole face of the abutment, all of the bearings were rusted, and so this is one of those minor items that if they had documented it a little more clearly, we could have gotten out and gotten the joint replaced and sealed it up and maybe not had to do a major rehab on the bridge quite as soon as we did. So that's just real quick look at what we're doing with our element level inspections. We're also doing quite a bit to ensure consistency with our inspection groups and also coordination between our inspection and planning groups. We've implemented a QC/QA process within UDOT where we go out and we field review 3% of our bridges. So we send our staff out and they re-inspect 3% of the bridges with the inspector's report and mark any discrepancies that we're seeing and document that. Then we also do a 1% QA, which is a desk review of 1% of our bridge reports every year. And it's that we compile all of those into a memo where we're seeing consistently items that are getting missed or consistently items that need improvement or inspectors should be focusing on more, areas where we're seeing a lot of variability from one inspector to the next and we're not getting consistency. So we compile all of that and we provide these marked up reports back to all of our inspectors so that they can see where the improvements are needed. And we also provide a memo once a year once we've completed our QC/QA of what our big focus areas are for the next year. Another area that we've implemented, it's been about 3 years now we've been doing this, and this is, I think, one of our biggest areas of where we're getting consistency between our groups and where we're really able to bring everybody together and also increase understanding. 2 times per year, we get all of our inspection teams together as well as all of our planners. We go out, we break up into teams of 2. Sometimes we keep it with standard inspection teams. Sometimes we mix up the teams so they can see how other groups are looking at things and how they're rating them and documenting them. And we go out and we inspect 2 bridges in the morning, and then we come back together in the afternoon and we go through every one of the inspections for each of the teams. And we look at where do we not have consistency, are there defects that are getting missed by some teams, and it really gives us an open forum to have everybody get together and talk and discuss, and if there's something that's unclear or something that we need to be improving on from a programmatic standpoint, it gives everybody that forum to sit and talk and have those open discussions and lead that forward. We also have our planners in the room at the same time, and so they're able to see what the inspectors are seeing. They're able to see in the field how it's correlating a condition state 3 to what they're actually seeing in the field, or if they see certain notes or certain defects, they're able to get that hands-on look at what the inspectors are seeing and what their different notes and their different ratings mean. And on the flip side of that, we've got our planners able to discuss back with our inspectors of, well, if you can put a little more focus in this area, or if you can document this a little more clearly, they're able to give the feedback back to the inspectors and have that discussion so that they're getting the information they need to do that high-level planning without having to make a site visit every single time. Because we've already got the data, we've already got people going out and looking at the bridges every 2 years, so if we can utilize that, it stretches our resources and makes it a lot easier for our planners to be able to do those evaluations without driving 6 hours to a far corner of the state to go take a look at something that could have easily been documented by our inspection teams. Another thing that we do is once a month we have an inspection findings meeting, and this is when we bring in all of our inspection teams. We do about 40 to 50% of our inspections are done by consultants, and then 50 to 60 is done in-house with our inspection teams. We bring everybody in. This is when we assign out the bridges to the different groups. We talk about any special considerations they have to look at when they're out in the field. If there are certain bridges, we talk about our fracture critical and scour critical bridges ahead of the inspections. But we also bring back any particular findings that there were from the month before. Maybe it's not something that's a safety critical item necessarily, and it's not something that they need to call us right away on, but it's something they want to kind of highlight and bring to our attention. If we're starting to see a lot of rapid deterioration, or we're seeing a lot of changes in the field, or we're seeing leaking joints that are causing issues, this is kind of a forum for them to be able to bring it up to our planning staff and to me to let me know that this is something that maybe we need to look at programming in the future. So with our element level data, we've developed a bridge health index that compiles all of that data into one composite number for the entire bridge. It looks at each of the condition states for each of the elements and compiles it together, and then it lumps it by what the component is. So all of your elements within the deck get lumped together, all of the superstructure gets lumped together, and all of the substructure gets lumped together. And each of these get a weighting factor. There's a little bit heavier weight on the deck components than on the superstructure and substructure, because defects in your deck are the ones that people are seeing with the riding surface. There are also the issues that can lead to further issues in other components of the bridge, so that's weighted a little bit heavier. And so we've set our performance targets based on the health index, and this is also part of our prioritization ranking. We take our health index and we have reduction factors for some of our NBI ratings in order to bring higher focus on some of the bridges for project prioritization. If the bridge has a 4, the health index is cut in half for our bridge planning index to kind of help all of those rise to the top. And also any bridges that have 2 5s get a reduction factor as well, because those are the bridges that are probably most likely to go to poor condition next. And so it kind of puts those focuses on addressing the low fare bridges prior to them falling into poor, or at least getting them on the program, because it's really likely that within the 4 years of our STIP, it will end up falling into that poor category. And so we'll proactively have it programmed before it hits that poor condition. We look at a couple other factors. We look at the load ratings on the structure. If any of them are load rated less than 1 and require posting, they get a reduction in the bridge health index to increase its rank on the prioritization. And we also look at traffic volumes, the detour links that go into it, and the span lengths. And we've got a bridge management manual on the UDOT website, and it goes into a lot more detail on what all these factors are and what plays into the bridge health index. So if that's something that you want to look into, we do have that publicly available on our website. So in 2012, Utah had all of the structurally deficient bridges programmed within our 4-year STIP. We've had a couple more become structurally deficient since then, but we've programmed them within the next cycle on every one of those. So right now we have all of our structurally deficient bridges programmed within a 4-year cycle. But what we're seeing is, as we decrease our percentage of poor bridges, we're seeing our fair bridges climb quite a bit. This is our NHS system, and off the NHS we're seeing an even higher increase of those fair condition bridges. A lot of times our NHS bridges are getting covered in capacity projects and getting addressed maybe before they hit the poor condition, and so we've replaced a major portion of all of our interstate bridges within the Salt Lake area and surrounding areas just with larger capacity projects. But those outliers off of the NHS, we're seeing a lot of them in that fair condition, and that fair condition is increasing every year. So that kind of put our challenge of, we're not looking at a worst first anymore. We're not necessarily just doing replacements and rehabs, because we've addressed those structurally deficient pretty effectively. So now we're at a point where we need to be looking at what can we do to extend the amount of time that a bridge is in good condition or fair condition, so that we're not dropping into that poor condition. About 30% of our inventory is exceeding its design life now, so we're expecting a lot of those fair condition bridges to start dropping off. And so if we don't start getting ahead of it now, we're going to get into a situation where we can't program every one of our structurally deficient bridges every year. So we've been looking at our preservation programs pretty significantly. We've got 3 main programs that we're looking at right now. We try to get an overlay on every one of our bridge decks. We're getting away from asphalt overlays, so it's either a thin bonded or a polyester concrete that we're using most of the time. So we've got our bare deck overlay program. We've got a paint program, because that's a fairly inexpensive treatment that you can do to effectively manage and extend the life of your major component with your steel beams. And also columns. If we can get out and repair the columns when they're in a damaged state that are still able to be repaired, we can maybe avoid a full bridge replacement by repairing those columns and extend the life of the entire structure. So the challenges kind of come of how we are going to start prioritizing projects for our preservation program. As part of our health index, our bridge health index is made up of all the different elements and the health indices of each of the individual elements. So we've started breaking out our overlay health index and our paint health index as a separate item and started ranking bridges by that. Our bridges that have a bare deck are considered an overlay health index of 0, so they're rising to the top pretty much every time right now as we're trying to address those. But we'll pull some of the bridges off the top and address bare decks, but we're also looking at the ones that have severe defects in the overlays as well. And so we're kind of breaking the list into all of the 0s and then all of the low health index on the overlay. And we try and map these out once we have them ranked so we can look for geographic areas that have a bunch of bridges in the same area so we can get economy of scale. We can program them as one project, use the same traffic control and mobilization costs to kind of reduce that by packaging them as one big project. We're still kind of working on the paint health index, and we're still trying to get a good handle on the element ratings for our paint systems, but we are in the process of working on our paint health index for that as well. And we've looked at our column health index, and we've started geographically looking at those as well so that we can lump them into one large project. So once we have our projects identified, we go into our scoping phase of it, and this is where, once again, we step into that inspection information. We're looking through all of the work candidates on the identified bridges, and we also print a summary report where we've got all of the condition data, and it helps us really early on to identify what work items are needed, what items we want to do, and maybe if there are defects that aren't critical that we don't want to do work on, we can identify that up front and include that in our scoping so that we've got it identified once it goes to a project of this work is being done or this work is not being done and the reasoning behind it. But this is all fed by our inspection group as well. And so we're utilizing a lot of that data both in the planning and in the scoping as far as selecting projects and then developing the projects that are going to be done. And that's all that I have, if you guys have any questions.
Scott Snyder with PennDOT. We're looking too at more of our bridge elements, of course, with the ASHTO elements, looking to focus on trying to get the more out of our inspection data for asset management, similar to we'd like to get, I think, where you're at Utah. You have anything specific like for condition state 4, you're looking at this type of deck preservation project, this type of installation here, anything like that?
We're looking more kind of what our ADT is and what the functionality of the bridge is, and not so much the condition state. We do look at our condition states and our NBIs a little bit when we're deciding between is this effective to pothole patch the deck, or do we need to be looking at doing chloride testing and see if it's a feasible candidate for hydro demo. Once we get about 25 to 30% pothole patching, so our condition state 3 potholing, then we start looking at is this a viable candidate for hydro demo. And so we do use that some.
Hi, Dave Johnson in Michigan DOT. Is it the BRM software you're showing when up there? Is that what you're using?
Yeah, we are using BRM.
Okay, great. And with regards to your health index, are you able to relate that to good, fair, poor, or you need, or is it primarily for something to compare and prioritize to?
We use it as a performance measure. Health index of 80 or above is good, 60 to 80 is fair, and below 60 is poor. And so we kind of look at that as well. If it's in good condition, we're looking at preservation treatments. If it's in fair, we're looking at rehabs generally with our health index, and then poor, we're generally looking either a really major rehab or a replacement.
On your day where you go out with the teams and compare notes, is that in-house or consultant teams also?
It's both. We
Both?
get
Okay, good.
everyone out there.
Okay, and the second one, you mentioned you're starting to record the defects behind the condition states, what are causing condition state 3. Have you you will come across, if you haven't already, if you have a column, for instance, which is each, and you have 3 different defects, all are condition state 3, picking which one you're going to choose as the controlling or the one you're going to call out as the reason, so that if you decide it's always exposed rebar, then it's going to look like you have a lot of exposed rebar, but you won't know that there's significant cracks, or some other defect that could drive it?
So the way we've looked at prioritization for it is kind of from a holistic planning standpoint. The highest priority defect is the one that we're going to actually do a treatment on. And so if you've got cracking, efflorescence, and a spall in the same area, and you're doing that prioritization, you would put the spall as your major defect because that's the one you're going to go out and treat. If you just have efflorescence and cracking, you would look at the cracking because you'd go seal the crack. You're not necessarily going to go wash off the efflorescence. So that's how we've kind of been running that.
Does this mean that, are all your inspectors in a centralized office, or how do you deal with the big geography of your state?
Yeah, we're all centralized, so generally we have about 1 week a month that our inspectors are out of town, and so they just travel and stay out of town for that week. We've kind of set it up so that if it's, around Thanksgiving and Christmas time, we've got our inventory set up so that you're staying in the Salt Lake area for those inspections, and but yeah, we're all out of the central.
Yeah, I was wondering, the collaborative peer review meetings that you have you included the maintenance crews in those meetings and the people that are actually dealing with the work orders that you generate?
We haven't included them at this point. We've got a bridge emergency and maintenance coordinator, and he goes out once we finish all the inspection reports for a given station. So we've got our cycles set up so that we're doing a full maintenance station at a time. So once we complete all the reports for that, he'll actually go out to those maintenance stations and sit down with them and explain what they're seeing in their report and what the work items are and help them kind of get an understanding of the prioritization. So at this point, not as part of the collaborative peer review, but we do have that coordination.
I'm a bit confused. When you're using this deterioration modeling, are you using it for asset management funding level, or are you using it for project-specific, action-oriented task?
We're using it for the project specific, not necessarily the funding levels. We did look at it from a funding level standpoint about 3 or 4 years ago and approached our legislature with our bridge health index and where we're at and where we were projecting it would be with our current funding. And we were actually able to about double our budget by providing that information.
Is there any specific reason why you dropped asphalt overlay?
We've seen a lot of accelerated deterioration of our decks when we've got the asphalt overlay on them, and also the inspectability of the bridge decks. We don't know what the condition is generally underneath the asphalt until we peel it off, and so a lot of times we don't know what's happening or what the condition of the deck is until we start seeing major deterioration to where it's showing through on the underside of the deck.
I'm Jim Leeden, Kansas DOT. Do you guys do electronic data collection in the field?
We don't do a lot. We have recently done a couple pilot projects with GPR and infrared thermography.
No, I mean the inspectors.
Oh, the inspectors?
Are they doing are they doing it on tablets or?
No, BRM right now doesn't have a tablet-based interface, and so they're taking their laptops out in the field, and we're using the standalone database, and we do direct our inspectors to input all of the data into their laptops in the field when they're at the bridge.
So the language they are using, is it from drop downs, or are they just typing it in, or talk to text, or?
With the element level data, it's all just open text where they're typing it in. It's not drop downs on that.
So it makes sense then what you're talking about, getting all the language correct between them so that there's not the confusion, so.
Yeah, with our work candidates, it's all drop downs and it's specified ahead of time, but with the element notes, it's open language.
Thank you very much, Becky. Very
you.
good presentation.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.